Here's our last lesson in our mini unit on trigonometry, and we're going to continue finding missing sides of triangles using our trig ratios with a little added kink in things today. So this should look very similar to the problems we did in yesterday's lesson, and we're just going to find that missing value there. So let's go about this the same way we went about it yesterday. Here's our three ratios. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Now, in relationship to this 12-degree angle, the side we're trying to find is the side adjacent to that angle. And the side we're given is the side opposite. Now, tangent is the only ratio that we know that uses both adjacent and opposite. Now, it happens to be in a different order, and that does matter. Here's how the setup is going to change based on that. So tangent of a 12-degree angle should equal its opposite 17 over its adjacent x. This is different from yesterday because every time we did it yesterday, the missing piece was on top. Well, that's not always going to happen. It'll happen 50% of the time, I guess. We'll use our table of values here. Tangent of a 12-degree angle is 0.2126. And what we do now is we multiply both sides of this equation by x. 0.2126 times x is 0.2126x, and 17 over x times x is 17. And then we solve this equation by dividing both sides by 0.2126. 17 divided by 0.2126 is about 80.0. So that's what this missing side is, 80.0, about. And we could use Pythagorean theorem to figure out the hypotenuse, or we could use another trig ratio. All right, let's go through this a couple more times. Here's our trig ratios, sine, cosine, and tangent. We are looking for the hypotenuse this time, side across from the right angle, and we're given the side opposite of a 72-degree angle. The only trig ratio we know that uses these two sides, opposite and hypotenuse, is sine. So we'll set this up as the sine of a 72-degree angle equals its opposite 15 over its hypotenuse x. Sine of a 72-degree angle from our trig table is 0.9511. You multiply both sides by x, and then you divide both sides by 0.9511, which is about 15.8. So in a right triangle that has a 72-degree angle, with a leg length of 15, the hypotenuse would be 15.8. It's very similar to yesterday, except we've got this added step. So make sure you show your work. One more time. Sine, cosine, and tangent. You know, the biggest question I get when I teach trigonometry is always, how do you know which ratio to use? I've tried to be pretty consistent in explaining how, I choose which ratio I'm going to use. Here it is one last time in notes. The first thing I always look at is the side that they're asking me to find. This time they're asking me to find the hypotenuse, so I'll label it hypotenuse. And then the second thing I look at is which side I'm given. Sometimes I'm given both the other sides, but if I'm given this 45, what is that in relationship to this 32-degree angle? It is the adjacent side. So which ratio am I going to use? The only ratio I can use is the ratio that involves both hypotenuse and adjacent, which is right here, cosine. Uses adjacent and hypotenuse. So I'll say the cosine of a 32-degree angle equals the adjacent 45 over the hypotenuse x. And then from here it's all procedure. Cosine of a 32-degree angle is 0.8480. Got that off the table. Multiply both sides by x and divide both sides by 0.8480. which is about 53.1. All right. So hopefully this is all coming together for you. If you watch yesterday's lesson again, that might help to really cement things in your mind. One more. Let's do a real-world example of this. Johnny is standing 10 feet away from a statue of Mr. Kuzinski. Why wouldn't they make a statue of Mr. Kuzinski? He has to look up at a 75-degree angle to see the top of the statue. If Johnny is about 5 feet tall, how tall is the statue? I think a picture is going to be necessary here. So here's our statue of Mr. Kuzinski sitting up on a cement podium there. Obviously got some rippling muscles there. And here's Johnny, and he's about 5 foot tall. Now he's looking straight at the statue, which he's 10 feet away from. We're trying to figure out the height of the statue. That creates a right triangle. Trying to find the height of it. Now, which sides am I working with here in this right triangle? Trying to find the opposite, the height, and we're given the adjacent, 10. So that would be tangent. Tangent uses opposite and adjacent. So the tangent of a 75-degree angle is the opposite side, the height, x, over the adjacent side, the distance we are from the statue, 10. Tangent of a 75-degree angle using our table is 3.7321. Multiply both sides by 10, and you get about 37.3 feet. Now that is not our answer. That's not how tall this triangle is, or that's not how tall this statue is. To actually find out how tall the statue is, we need to add Johnny's height to the height of the statue. That's how tall the statue is, which is going to be 42.3 feet. Sorry, you can't see that. Didn't use foresight very well on that, but it's 42.3 feet because we have to add Johnny's height. So this is 5, this is 37.3. Together, they make the entire height of the statue about 42.3 feet. All right, so come in with your questions tomorrow, re-watch the video if necessary, and good luck to you.